This video is in continuation with our earlier video where we had discussed about the LCD interfacing with the microcontroller. Probably if you look at this particular section of the block diagram, you can recall what we had discussed in the previous video. We have basically 8 lines, 3 of control lines and 8 of them are the data lines. Here we are going to discuss how to receive the character from the hyperterminal. When the 8051 receives data via RxD, it gets rid of the start and stop bits and places the byte in the serial buffer of the microcontroller. RI, the receive interrupt bit, is raised to indicate that a byte has been received and it has to be picked up before it is getting lost. The baud rate at which the data is being transmitted is determined by the count loaded in the TH1 register of the timer configured in mode 2. Our main emphasis here is to illustrate how timer can be programmed to generate the necessary baud rate. This diagram illustrates how the LCD is being interfaced to the microcontroller, point number 1, and on the other hand, how the microcontroller is going to receive the data from the PC via the serial port. The embedded C program to receive the character and display on the LCD is shown here. This particular program comprises of functions such as LCD, delay 1 in order to generate the delay. As said in the previous video, we need to initialize the LCD, and the LCD underscore init is the function that is being used to initialize the LCD. In order to initialize the serial control block of the microcontroller, we have the serial init. We have another function called LCD, and you already know that the control starts from the main function. The initial lines, that is the delay 30,000, will be stored in the keyword delay. Then port 3, 5th bit is initialized for register select. Similarly, port 3, 4th bit is registered for read write. Enable is registered for port 3 and 3rd bit. When the control starts from the main function, the LCD initialization is going to happen. So the LCD is being initialized by using these statements: 0x 38, 0, 01, 0e and 0x. That will do the necessary functions such as clearing the LCD, displaying the on, so on and so forth. That is being discussed in the earlier video. Then after initializing the LCD, we are going to initialize the serial buffer of the microcontroller. Once this particular function is called, the control will be transferred here and the T-mod is loaded with 20, the serial buffer is loaded with 50, TH1 is loaded with FD, that which is equivalent to -3. So here -3 refers to 9600 baud rate. So this is where we are going to load or decide the baud rate at which the data needs to be transferred. Accordingly, the value of count that is to be loaded into TH1 varies. Then the TR1 bit is made high. After the execution of these statements, the control will come back to the main function. So it is an infinite loop while 1. LCD is 0x80, 00. When this particular function is being called, the control will be transferred here. 80 will be copied into the ADDR variable. 0 will be copied into flag. So this AT is being done in order to display the character in the first row in the first line. First character in the first line or the first row. Okay. Suppose if you want the display to be displayed in the middle of the line, accordingly you can change the value of the ADDR. Then the register control select is made low since it is 0 here. The read write is made 0, that will enable us to write the data. As discussed in the previous lecture, the enable pin has to go from high to low. In order to ensure that the enable pin is made high and then it is made 0. We have calling a delay of 500. So when this particular function is being called, the control will be transferred here and the while loop will create a delay of certain seconds or milliseconds. Later on, the enable pin is reset to high once again. After this operation, the control will be transferred here. When the receive interrupt flag is set high, then Ri is equal to 0. The content in the S buffer, serial buffer, will be transferred to variable val. Then this character will be displayed on the LCD by using this particular function. After this, there will be a delay of few milliseconds, that is 15 milliseconds. So that means once the data is sent, after 15 milliseconds, this data will be displayed on the LCD screen. So this is the embedded C program to receive a character and display on the same on the LCD.